We'll talk about indices in details in this video. So simply, indices refers to the powers of numbers, and we have to consider some basic laws of indices and then transition to higher problems involving indices. So the first law of indices, not necessarily first law. One of the laws is that if you have a to the power of x multiplied by a to the power of y, then the powers we add, since they have the same base, so you have ax plus y. So what that means, if I have a to the power of 3 multiplied by a to the power of 3 or to the power of 2, let's give that, I will retain my base, which is a, but the powers we add, and that is 3 plus 2, to give you a to the power of 5. Now, if I don't want to use this law, if I say a to the power of 3, that is a times a times a, and then a to the power of 2, which is a times a. If you count the number of a's, 1, 2, 3, 4, 5, you still have a to the power of 5. So whether you use the laws of indices or the number multiplication, you still have the same result. And if I have a to the power of x divided by a to the power of y, because this is division, I will use subtraction as the operation. So my a will be x minus y. In the same vein, which means a to the power of 3 divided by a to the power of 2, like we have here, I will say a 3 minus 2, and that is a to the power of 1, which is just a. Now, if I use the normal division method to solve this or express this, I will still have a to the power of 3 divided by a to the power of 2. And this will be a to the power of 3 divided by a to the power of 2. And a to the power of 3 is a times a times a. And if I divide it by a times a, I will have this, take this 2 down, this a will remain. So whether I use normal division or the laws of indices, I will still have my result. Okay, let's try another law. If I have a to the power n, m, then multiply, okay, a to the power x, and then raised to power y. Now what I'll do is I will retain my base, which is a, but I'll multiply x by y, and that will be axy. So what that means, if I have a to the power of 3, then raised to power 2, to simply be a 3 times 2, and that will be a to the power of 6. And if I use the law of indices, this a to the power of 3, then raised to the power of 2 again, will be this a to the power of 3, multiply itself. Yeah. So by law of indices, I'll just retain my base and add the powers, which is 3 plus 3. And that will give me a to the power of 6. So you see how these laws are linked together. Now, if I have a to the power of 0, I have 1. This is another law of indices. A to the power of 0 is 1. How is this possible? So there are different ways. If I have a to the power of x divided by a to the power of x, they have the same base and the same power. This simply means a to the power of x divided by a to the power of x. And if I divide it 2, I will have my 1. Now, if I use indices, and since I have a to the power of x divided by a to the power of x, this will simply mean a to the power of x minus x. And that x minus x is my 0, which means this is equal to a to the power of 0, which is 1. And this 1 means a to the power of x divided by a to the power of x. So what that simply means is that my a to the power of 0, which is equal to 1, is the same thing as a to the power of x divided by a to the power of x, and that is going to be ax minus x. So it's the same thing. See how they are related. So if you do normal division, having the same base and the same power, you have 1. If you subtract the powers, you have 0. So a to the power of 0 will give you 1. Now let's try another law. Okay, so let's use one example. if I have a to the power of 3 divided by a to the power of 3, this will simply mean a to the power of 3 divided by this, and I'll have 1. And if I do a subtraction of it, this will still be equals to a to the power of 3 minus 3, which is a to the power of 0. You see, it is still linked back that a to the power of 0 is 1. They are what we call laws of the transitive law in logic, that if A is equals to B and B is equals to C, and it means automatically that A is equals to C. When we discuss logic, we'll come to this aspect of indices. Now, these are different laws. Let's also try what we call fractional law. Fractional law of indices. That one says that if you have A to the power of 1 over n, okay, this will simply mean that I'll have the root of A, then I'll have my A all to the power of 1. So of course, this is not important. What that means is, if I have A m over n, I'll have my root being n, I'll have my A in the bracket, then I'll raise everything to power m. And so if I want to rewrite this now, this will now become A to power m multiplied by 1 over n. Okay, so remember this law here. So my m is x and my y is 1 over n. So if I multiply them out, I will still have my a m multiplied by 1 over n, and that will still give me a m over n. This is the fractional law of indices. So what that means is, if I have a to the power of let's say 4 to the power of 1 over 2, what this means here is that I'll raise this, I'll reduce this 4 to a base that is equals to this half. What is the half here? This is 2. I will turn this 4 to have a base of 2. So this will be 2 to the power of 2, then multiply by half. So you can see this half, this 2 will cancel this 2. So 2 to the power of 1 will give you 2. So this is how we have the laws of indices operating many places. So how do we apply some of these problems using these laws of indices? Because I'm going to give examples on the board and solve. Okay, so let's work on these examples here. So this first one is 3, 2 raised to the power of 3 over 5. So 3, 2 raised to the power of 3 over 5. Now what I have here is 32. I'm going to check what I can convert 32 as if I have a base 2. So 32 simply means 2 to the power of 5. I want to make sure that when I convert my base and have a power, it must tally with the fraction, the denominator of the fraction. So this will be equals to 3 over 5. So what I'll be having here is 5, 2, then this 5 will multiply this 3 over 5, 3 over 5. So this will cancel this. So my 2 will be raised to the power of 3. So 2 will be raised to the power of 3, and that is 8. Now the second one, this is 1. The second one, which is 2, is 25 to the power of 1.5. And if you look at this closely, 25 simply means 1.5 means 3 over 2. Now my aim is to work on the denominator alongside the 25. So I'll raise 5 to the power of 2 so that it will tally with the denominator. So this is 5 to the power of 2, and then I'll have multiplied by 3 over 2. So this is going to be 2, we cancel 2 here. So I have my 5 to the power of 3, which is 125. So whenever you're solving, you make sure that whatever you raise, whatever you convert this number to, it must have a power that will cancel the denominator of the fraction. Okay, so this is number 3. Say we should solve 2x equals 0.125. Now 0.125 simply means 125 over 1000 or 1 over 8. So how do we know? Let me do it 125 over 1000 so that you know how it is 1 over 8. 5 go here will give you 25. 5 go here will give you 200. Now 5 go here will give you 5. 5 go here will give you 40. So that means my 2 to the power of x will give me 5 over 40. 5 go 5 will give you 1. 5 go 40 will give you 8. Fine, but what I have here is 2 to the power of x. I have to do the same thing to 8. So I can write this to be 8 to the power of minus 1, because any number to the power of minus 1 is 1 over that number, which is one of the laws of indices. Now I will have 2 to the power of x. I will raise this 8 to be 2 to the power of 3 minus 1. So 3 times minus 1 will give you minus 3. So this will imply that 2 to the power of x will give me 2 to the power of minus 3. So 2 and 2 take down themselves because they have the same base. Therefore, my x is equal to minus 3. So this is how you solve this kind of problem. Now, the number 4 says that my 4 over 2 to the power of x is giving me 64x. So what am I going to do? I'm going to make sure that now I can convert this as follows. I can multiply, I'll convert all of them to base 2 first. So this I'm having here is simply 4 multiply 2 to the power of minus x, that is this, and then this is equals to 64 to the power of x. Now we'll convert all of them to be in base 2. So this will be, this 4 is simply 2 to the power of 2 multiplied by this 2 is 2 to the power of x, and then 64 is 2 to the power of 6. So I have 2 to the power of 6, and I have x to it. So this is 2 to the power of 2 multiplied by 2 to the power of minus x, and then this will give me 2 to the power of 6x. Now this is multiplication, so I will add it together. So this will give me, my 2 will be retained, 2 minus x, and this will be 2 to the power of 6. So now they have the same base. I will equate their powers. So my 2 minus x will give me 6, and this will imply that my x will be equals to 2 minus 6, and 2 minus 6 will give me minus 4. So the value of x to satisfy this equation is minus 4. And let's go with 10x equals 1 divided by 0.001. So let me solve that one here. Let me use this space. Now I have 10x raised to the power of 1 over 0.001. Now remember, in indices, if you have 1 over a, it simply means a to the power of minus 1. That is one of the laws. Okay, so now this is going to be 10 to the power of x will be 0.001 to the power of minus 1. Now 0.001 by laws of indices is 10 to the power of minus 3. Why? Because if I have 0.001, if I do standard form, I will count 1, 2, 3, and this will be 10 to the power of minus 3. If I do division, I will have 1 over 1000, and this is going to give me 1 over 10 to the power of 3. Now because it is 1 over, it's going to be 10 to the power of minus 3. So what I'm going to have here is 10 to the power of x will give me 10 to the power of minus 3. And so they have the same base. My x will be equal to minus 3. So that is how you can solve that type of problem. Now the last one, which is 25, you have 25 to the power of 5x will give you 625. Now this is 25, this is 625. So this is a factor of 625. So the next, I'm going to raise 6 to 5 using 25 as using 2 as the power of 25. So this is 25. I have 5x, and this will be equals to 25 to the power of 2. So if I solve that, they have the same base. My 5x will be equals to 2. So if I divide both sides by 5, and both sides by 5, you can see that my x is equals to, this cancels this, equals to 2 over 5. So these are basic problems involving indices. So in my next video, I'm going to talk about exponential equations and how they are solved. So stay tuned and enjoy the class.